In this video, I'm going to look at one problem from WebWork. We're going to use the data that's there, plot a scatter plot, plot a regression line, and calculate the equation of the regression line using R. So here's the problem. We've got 7 supermodels. We've measured heights and weights of each of those supermodels, and we'd like to know what the regression equation, the linear regression equation for that data is. So the problem is we need to get this data into R. There's a number of ways to do that, and this is a very small data set, so there's a lot of really kind of quick, easy ways to do that. I'd like you to learn how to create a data frame so that you can handle larger data sets than this. The idea with that is to go to some word processor, maybe like WordPad. I'm in a Linux environment, so I'm using a little bit different word processor. I'm using gedit, and just create a comma-separated file. The first row in that file is going to be the header. We're interested in heights and weights, and they're separated by a comma. Then for each one of the 7 models, we have their height separated, comma, their weight. And so there's that data sitting there. Now I need to save this data in a location that is going to be my working directory in R. So I'll saving stuff varies with the environment that you're in. I don't want to save it in Documents. I want to save it in Documents and a subfolder in there called R. That's where I personally am keeping all of this stuff. I'm going to name the file supermodels.txt, and I'll just save that file. Okay, so there we looked at the problem, we built a file, we saved that in the working directory of R. Let's go to R now for a minute. Here I've been playing around a minute ago. Let me clear that out and show you what we're going to do. The first thing that I want to do is get my working directory. I want to see what my working directory is. Let me just start this fresh, if you don't mind. Sorry for that bit of a delay. I'm going to start up R. So there's the startup. I got a fresh version of R. I want to look at my working directory. Get working directory, open and close parentheses. It tells me that that's where it is. Your working directory, depending on your computer environment, in a Windows environment, you usually have a C colon, and they use backslashes instead of forward slashes, and so on. But there's some real similarities here. That's not where I want mine to be. I want my working directory to be in Home, Will. I want it to be in Documents, and I want it to be in that folder R. And the name of that working directory needs to be in parentheses. So I've reset my working directory. Now, usually when I reset a working directory, I like to go back and get my working directory and verify that that's really where I want to be. Okay, that's the right place. It was in this directory that I saved that particular file. R can help me see files in my working directory by using the command list.files and then open and close parentheses. That means it's going to list the files that are currently in the working directory. I've got a pile of them there, and look down the list. There it is. There's the one that we just now created, the supermodels.txt file. Okay, I'm interested in getting that file into R. Here's the command that does it. A read, comma, separated file, CSV, and then I I name that file that we're interested in. Our file was supermodels.txt. In my case, I think you have to worry about whether it's capitalized or not. This is case sensitive stuff. So we read that file, and sure enough, there's that data. There's the file read in as a data frame. So it gives us the heights and the weights and the information that's there. The problem is the way that we saved, the way that we read that right here, we didn't do anything with it except just print it to the screen. So R has forgotten about it. We need to save it as an object. So I need to make up some name for the object. I'm going to call it SM for supermodels. I could either use an equal sign, or most people that use R use a less than sign followed by a minus sign, so it makes that little arrow, meaning that we're going to move the stuff on the right into this object, and the stuff that we're going to move in is this data frame that we get by reading this information. Supermodels.txt. Okay. Now, in this case, it didn't print anything out because we told it to store that into this object SM. But now, anytime that I ask for that object SM, it will show me that data frame. Now, there are some things that you should know about these. We will soon look at data frames that have over 20,000 rows in them. And so asking to show the whole data frame would be a real pain in the neck. There's a nice command that is called header. If we looked at the header of SM, I'm sorry, the command is head, then it will show you the first 6 rows of the file. In this case there, I'm sorry, I was telling you that it was header, but it's called head. The head of a data frame will show you the first 6 rows. That'll let you know what the header is in the data frame, and it will let you see the other information that's available in that data frame. Okay, in this case, head is kind of a silly command to use because there's only 7 lines, and head just shows you the first 6. But if you had a data frame that had 20,000 items in it, you don't want to see that whole thing. You just want to see the top of it so that you can see what these things are in the top of that. Okay, so we can ask R to tell us what these columns are. For example, SM is the data frame, and I want to have the information that's in that column, the height column. So it gives us that data that's in that column. Similarly, we could look at SM $weight, and that would give us this other data that's here. That means it's really easy to do a plot of, I'm going to think of the X values as being SM $height, because I want height to be the explanatory variable, and the dependent variable is going to be SM $weight. And let me pull that over so you can see it. There's that scatter plot. It seems that those points are really kind of fitting more or less in a line. I mean, it's not exactly, but certainly as these supermodels get taller, then their weight seems to be increasing. That's really kind of what we would expect in these situations. Okay, the next thing we need to know is a command that's called LM. It stands for linear model. In linear model, we're going to look at SM $weight, and then a tilde sign. That's usually up in the upper left-hand corner of your your keyboard. You sometimes have to use this shift command to get to it. $length, Length. Okay. Now, what this linear model does, it tries to explain this first variable by this second variable. Okay, so we're thinking of the, I'm sorry, that length is the wrong thing, isn't it? SM height. So we're thinking of the weight being explained by the height. So we're building a linear model of the weight by the height, explained by the height. When we do that, then it gives us some information here. It gives us the formula information. It tells us that the y-intercept of this straight line is going to be a negative 72.50, and that the slope of this thing is going to be this amount. So it's telling us essentially the equation of the line for this by telling us the y-intercept and the slope. Now, we've already, let me just go back and remind you, we already did this plot. We want to add that line, the graph of that line, into this plot. We'll be able to do that. If you've already got a plot started, you can do AB line and put into AB line a linear model. We want the linear model that is involved with SM weight tilde SM height, G-I-G-H-T. Okay. Now what that did was add that line to the graph. Notice we didn't say plot again. We wanted to keep the same plot that we had, but it's this AB line that will plot a line, a straight line, from a linear model into an existing graph. Okay, so we've got some interesting data here. We know that the x-intercept is that negative 72.150, and our problem up here, notice that the way they've got this written, this number here is the y-intercept and this number is the slope because it's the one that's timesing x. So we want to insert that particular amount. Did anybody remember what that is? Let me go back and find that number. It's negative 72.150. Let me get over here. So negative 72.150, and the slope was also given back there as 0.725. So let's come back here as 0.725, and then we've got to do a prediction here. What does this model, what does the